All right, this is how thermostat works. So for today, I'm going to be using a Honeywell Focus Pro 5000. It's a pretty common thermostat. This is the panel that's underneath what you normally see, which is this right here. And this can be used for a conventional system, which is electric heat with an AC, gas heat with an AC. That can be propane or natural gas. This thermostat can be used with a variety of things, but you have a wiring designation up here for conventional systems and one on the bottom for heat pump. I've got this wired up, or I'm going to configure the thermostat for a heat pump. And the principles of how this work are the same for digital thermostat or analog, the old mercury style or the spring activated. There's always going to be wires that serve a purpose. So starting with R here, that's the 24 volts coming in from the transformer. So the thermostat takes that voltage and it applies it to each one of these other terminals depending on what's being called for, whether you're calling for heat, cool, then you have multiple stages of heat and cool. You might have 2-stage cool, 1, 2, or 3-stage heat. So it depends on how you configure the thermostat or what your thermostat is designed to do as to where it directs the power from this R or RC into these other terminals. But for this video, this is going to be basically a 2 heat, 1 cool heat pump system, or heat pump with auxiliary heat. So R is coming from the thermostat, that's the 24 volts. R and RC are jumped out. We won't get into what that's all about, but it's for systems that have 2 transformers, so you can separate the 24 volts coming in for each transformer. Y is going to be yellow for this configuration. Y is the compressor contactor. So the thermostat, depending on what you're calling for, it may send 24 volts to Y, which is going to go to the control side of your contactor that controls, well, we're going over a heat pump here, so the contactor on the outdoor unit or condensing unit to engage that. C, the only purpose that C serves coming to the thermostat is to power the thermostat. So I've got batteries in this one right now, but you can take these batteries out, being that C is here, and the unit will provide power. We like that setup without the batteries, and we tell our customers that if the thermostat ever goes blank, that means there's a problem. Putting batteries in it will not make the unit work. So that is the only purpose C serves. C isn't designated to any terminals. It is only here to close that power supply to the thermostat. All right, and then we've got OB here, which is the reversing valve. O is going to be for all units except for ream and rud. B is for ream and rud. So an O designation means that there is power supplied to this terminal, the O terminal. We're using the orange wire here for systems where the reversing valve needs to be energized in cool mode. So that means when there's a call for cool on the thermostat, when you've set your thermostat lower than what the temperature actually is in the home and you have it set to cool and it turns the unit on, it's going to send voltage through this wire to engage the reversing valve. On the other hand, for ream and rud, the B terminal or B designation means that when there is a call for heat, it sends the voltage to that reversing valve. So the opposite is true for O. When you're calling for heat, there is no voltage sent on the O terminal, because that means it would be in cool mode for O, and the opposite is true for B. So B designation or ream rud, when you're calling for cool, there is no voltage supplied to O. B, it's the same thing. O and B just designates whether or not you're energizing that terminal in cool or heat. All right, moving on. G, or green here, that's for the blower fan, the indoor fan, the fan that circulates air through your ductwork and across your air filter. Okay, so that R, the power coming into R, is going to get sent to G when there is a call for cool, heat, unless you have a furnace, then a gas furnace. Typically the furnace will turn the fan on and off when there's a call for heat. All right, but we're using heat pump here, so G is going to be energized basically anytime there is a call for anything, or if you call for the fan to be on. All right, moving on to aux, auxiliary heat. So when your heat pump can't keep up, or you see the auxiliary heat light come on the older thermostats, or you see auxiliary heat come on your digital thermostat, it's sending a signal, or it's providing 24 volts to this terminal, which is going to be a sequencer, a relay, or a contactor to turn on the heat strips, which is your auxiliary heat in your indoor unit, or if you have a package unit, it's the heat strips in your package unit. And then E here is for emergency heat. So some thermostats don't have that option. This one does. You can call for emergency heat, and it will only call for the fan. It'll energize G, and it'll energize this wire. And basically when you get into the unit, these two wires are the same thing. So it's calling for auxiliary heat. Emergency heat is just auxiliary heat by itself. It's not running anything other than the fan and the heat strips. Where when you see auxiliary heat come up, your first stage of heat, which is your heat pump, has already been energized. Now I'll go in and show you how this thing actually works, how we're getting voltage in here. So I'm gonna make sure this thermostat is programmed correctly. Gonna go through the settings here. All right, back with a new thermostat. We've got the Honeywell T6, which is what replaced the Focus Pro 5000. That's what it looks like. And I've rewired everything. Same thing, this thermostat has a few more features. It's capable of doing a few more things, so it has more available terminals. But we have wired this up. The white backgrounded lettering is for conventional, heat pump, and the darker background is for conventional. The only thing that's shared is R and C and G, Y. So we got aux, E, OB, Y, G, C, and R. So one point I'll make is, I didn't take the time. You really don't want any of this copper showing, or if you do, you want to make sure it's in a way where none of the wires will touch each other. And we're going to power this thermostat up. Everything's still on, and I'll have to go through and program it for heat pump. All right, we are done. All right, now back to where I was. So we're gonna leave. Again, I'm just showing you how a thermostat works. This is not a troubleshooting video. It may help you troubleshoot if you ever need to, but we've got, you can't see the wires up there. Yes, now we can. Everything, we're not calling for anything on the thermostat. 16, 16. We're looking for 24. I think that we don't have this transformer grounded. We're getting some voltage feeding through onto some of the other wires, but basically this thermostat is not sending voltage through any of these wires, 24 volts, which is what's required to activate the contactors or relays and whatnot that they're going to. So we're going to call for fan on, and It's going to click. It takes it a minute. Now we're getting, it's 28 volts, but it's over 24. You know, as long as we're not getting up above 32, I think we're good. So we're sending that signal, and that's the G terminal in the thermostat. That's what the green wire was hooked up to, and it's not sending voltage on any other wire. Okay, now, man, it's 77 degrees. I don't know about y'all, but that's kind of warm for me. So we're gonna turn the air on, and 70 sounds good. Okay, now we're set this up for O, which means it will energize and cooling. So we should, if we're gonna cool the house, we need the blower fan to come on, we need the compressor and the outdoor fan to come on, which is the Y terminal, and we need to energize the reversing valve, which is the O terminal, which is going to be orange. So yellow, orange, and green, that's Y, G, and O. OB terminal on the thermostat. We're getting 28 volts on Y. We're getting 28 volts on O. And we're getting 28 volts on G. So that thermostat is taking the power that's coming in to the R terminal from the red wire, which is right here, which is what the hot from the transformer is connected to, and it's directing that voltage to each of those terminals when you call for cool. And we're not getting 24 volts on the heat strips, as we shouldn't. Okay, now if this were a ream or a Rudd system, we would have had the thermostat set up to energize the reversing valve in heat, which is what B means. Same wire, which is the orange wire, but when we're calling for cool, it would not energize the O wire, because on ream and Rudd, it needs to be energized in heat mode. All right, so now let's go to regular heat. And we've got to bring the temperature up. And this thermostat also has a 5-minute compressor protection delay on it. So I turned that off, I've disabled it, but if you were doing this and it's just flashing cool on, or it's not coming on, it may be in that 5-minute delay. But now that we're calling for heat on a heat pump with an O designation on the reversing valve, Y should be energized, G should be energized, and that's it, until auxiliary heat comes on. So we're getting 24 volts on Y. We are not getting 24 volts on O because we're heating. And we've got 24 volts on G, which is the green wire. So your thermostat has called for heat. It's taken the power coming in from the transformer on the R terminal and designated it to Y and G to run the fan and to turn the outdoor unit on, the compressor and the condenser fan motor, and we're leaving the reversing valve in heat mode. All right, so I'm not sure what the delay is on the auxiliary heat here. We'll wait and see if it comes on. All right, well, thought I heard something. Oh, okay. So yeah, it is calling for auxiliary heat now. See if we can't make it go off. All right, so there is no indicator of whether or not the auxiliary heat is on, but it did go off just now, but I'm thinking maybe it clicked off completely. So there's currently no active call for heat. Anyway, we'll come back to this. Let's go to emergency heat. So we should just get the E terminal and the G terminal, which will be green and black, should be energized. Yep, emergency heat on. Yep, there's 28 volts there. There's 28 volts on G. Nothing on Y. Nothing on O. I mean, we're getting the, oh, it is calling for white. So it energizes W and E on this thermostat model. On the Focus Pro, it just energized E. Some people stage the heat strips. Most of the heat strips that we install don't have stages unless it's in a communicating system. Let's go back to heat and see if we can't get just the heat pump on. I think it's already doing that. Yep, 28 volts on Y. Nothing on O because we're calling for heat. G is energized. W is not energized yet. Alright, so we're good there. Nothing on E. Let's go ahead and ramp this up to 82. Let's see if we get an indication on the thermostat of when. Alright, I heard a click, but there is no indication on the thermostat that auxiliary heat is being called for. So yeah, there we go. There's auxiliary heat. And now we're going to turn everything off. Alright, voltage dropped out. Shouldn't be anything energized now. Alright, that's it. That's how a thermostat works. There are some variations for different kinds of thermostats, but that's the basics. Please subscribe.